Hi everyone, this is Miss Graham, and today we are going to be looking at lesson 22-4, solving right triangles. So we're essentially taking everything that we have learned in activity 22 and putting it together. Go ahead and pull out pages 315 and 316. Our learning targets for today are we are going to calculate angle measures from trigonometric ratios, and we're going to solve right triangles. Now, before we actually go through the lesson, we are actually going to treat problem number 1 like a warm-up. So looking at problem number 1, this is going to be like a warm-up to review what you have learned so far this unit. So go ahead and you're going to take the time to read through number 1, go ahead and do parts A and B, pause the video here, and come back when you are finished to check your answer. All right, let's go ahead and talk about this problem. I know it's a little bit of a challenge as a warm-up, but that's okay. We all deserve a little bit of a challenge to kind of help review and help us prepare for our fluency check at the end of the week. So we were able to draw a right triangle ABC. Now, it doesn't matter what you label the vertices. As long as you know this angle A is acute, that means it cannot be the 90-degree angle. So we know it has to be one of these two up here. Obviously, I just put it down for here for placement. Again, B and C, it doesn't matter which one you put where. That's why I put them in blue, because we don't know if B or C is a 90-degree angle, as long as it's not A. We also know that sine A is square root of 3 over 2. So remember, looking at this, sine of theta, whatever our angle is, it always is the relationship of opposite side over hypotenuse. So this is going to be our opposite side of square root of 3. Our hypotenuse is 2. Again, depending on how you drew your picture, right, keep in mind that wherever your square root of 3 is, it's at the opposite side of angle A. So now, reviewing kind of, what we saw last week and the week before, we have some special triangles that we like to look at, 45, 90-degree triangles, as well as 30, 60, 90-degree triangles. We know there's a certain pattern with 30, 60, 90 degrees triangles. We know that if we have our short leg, that our long leg will be the short leg times root 3, and we know that our hypotenuse will be the short leg times 2. So let's think about this, right? We know acute angle A, what we're looking at, right? This is the angle, this is the side that's opposite from it. That's the hypotenuse. Okay, well, what if we created our triangle and modeled it off of here? Let's say we knew exactly what our long leg was. We do, it's square root of 3. Remember, there's an imaginary number 1 in front of that. So we could treat that as our long leg, correct? So really our short leg, this length right here, is going to be a length of 1. And to just double check, remember, to get the hypotenuse, it's the short leg times 2. Hey, what do you know? I take 1 times 2 and I get 2. So that's how I know that this relationship is a 30, 60, 90 triangle. Again, this is a little bit of a tough warm-up to kind of look at and figure out, but I wanted to challenge you with this. So it says determine what must be true about angle A using what you know about special right triangles. So keep in mind that was kind of our hint that we had. We were looking at special right triangles, and we really only know 2 of them, right? Equilateral is not a right triangle. So we know that, hey, from this pattern, that angle A has to be 60 degrees to follow that pattern. So that was definitely a good, strong warm-up for us to really go through. Now let's go ahead and start going down to look at the paragraph below. So it says in item number 1, you are given the sine of an acute angle A, and you are asked to find the angle whose sine is equal to that ratio. So in other words, you are finding an inverse sine function. So what we're really asking up here is for you to find the angle measure, right, to solve for A when we have this ratio. So going back down to what we have below, this inverse sine function is what we're going to look at today. So it says this is written as inverse of sine like this. So do you see how there's kind of this -1 there? That's how we're going to write it. If you ever see, a -1 next to cosine or tangent, that's the inverse of cosine or the inverse of tangent. And that, my friends, is how we are going to use to find angle measures. So we might want to make a note over here that inverse is used to find angle measures. So a lot of the time, like I said up here, we use theta for angle measures. That's what we're going to do with inverse a lot of the time. Now, we can write what we just came up with above, all right? We can write it as the inverse sine of our ratio of square root of 3 over 2. It's going to equal 60 degrees. So the expression, right, inverse of sine of x is read the inverse of sine of x, or inverse sine of x. So let's keep going. Let's keep exploring down below to learn more about inverses and maybe how we can find these in our calculator. So now it says the inverse trigonometric functions for sine, cosine, and tangent are defined as the following. So we're looking at, and let's say we have sine of A, and it equals x, right? That's our degrees. Then we could do, sorry, not our degrees, that's our ratio. A is our degrees. Then we can do the inverse of x. So inverse sine of x to give us the angle measurement A. So just like before, how we did it with sine, we can do it with cosine and tangent. So if I take the inverse of our ratio that they give us, so x this time, so inverse cosine of x or inverse tangent of x, we can find the angle measure. Now, I'm going to go off to the side over here, and I'm going to kind of show you what I am thinking in regards to this, what it's actually doing. So think about a simple algebraic example. Let's say we had 2x plus 1 equals 5. Okay, we know we would have to subtract 1 from both sides because, you know, subtracting is the inverse operation of adding. So we'd be left with 2x equals 4. And then you know we'd have to divide by 2 because the inverse operation of multiplication of 2x is division. So that's how we're able to solve for what x is. Now, we're having a little bit of some tougher problems going into geometry, right? So this is kind of what we're looking for. We're saying if I have sine theta, again, I could use A, but I'm going to use theta. I have sine theta equals square root of 3 over 2. What I'm essentially doing is I kind of want to cancel out this sign. I just want to get theta by itself. So what I technically have to do is I have to take the inverse sine of both sides. So we have inverse of sine and sine. Just like over here, you know, they cancel out. That's what happens here, you know. Sine and inverse of sine cancel out. So I'm just left with theta, whatever my angle is. Again, since we did the operation on this side, like over here, 5 and negative 1, they don't cancel out. We actually just perform that operation together. We do that subtraction to get 4. That's essentially what we're doing here. We want you to take the inverse sine of the square root of 3 over 2. Now, that's what we're actually going to show how to put in our calculators right now. So I want you to go ahead, pull out your graphing calculator. I'm going to go ahead and pull up Calculator X and show you how to kind of walk through, and we are going to input this into our calculator. All right, so I have Calculator X pulled up. I kind of took a screenshot here, and I'm going to really walk you through what buttons to press in your own calculator so we can actually figure out, hey, how do we get 60 degrees as a result here? So if I zoom in a little bit, hold on, let's go ahead and zoom in here. Hold on. There we go, perfect, okay. You can see the buttons that I'm working with, right, are not just the sine, cosine, and tangent, but do you see these buttons? Those are our inverse buttons. So that means we have to press the second button first before we click this. So in order to type this in the calculator, I first want to click the second button, then I want to click sine, so that way it's going to pop up the inverse of sine. And then I want to type in the square root of 3 over 2. Now, sometimes just to be safe, I always add extra parentheses. Sometimes you might see me add an extra set of parentheses kind of right here just to be careful. But that's okay. We don't have to add them. I just want to make sure that we know the square root sign is only over the 3. So, again, remember, we've already typed in second, the sine button. And then here's what you're going to do, okay? You're going to type the second button again, and then the x squared button because we're trying to pull up that radical. All right, so in our calculators right now, we should have where it says sine and that -1, so that's inverse of sine, and then you clicked the square root button. You typed that in. So now we can type in 3. And one thing that's really important is you want to make sure that this square root button doesn't really carry on. So sometimes people like hitting the next button just to make sure, okay, what we're going to type next is not under the square root. So when we do that, we want to make sure we're dividing next. So you want to hit the divided by symbol. It's going to pull up and look like that. Again, if you see something where this is being carried over and everything's under the square root, that is not correct. So make sure that you don't do that. So then we're going to type in next is we're going to type in that number 2. So this is, let's try again. This is what should pop up. And then what we want to do, since we have parentheses around this, is we want to close our parentheses with that symbol. So we initially were given a parentheses already, and that's what we want to type in. Now, sometimes, again, like I said, if you want to put that extra set of parentheses, I will walk you through how to type that in as well. So again, we could start off by saying second, and then hitting our sine button. So what's going to happen is we're going to get the inverse of sine. Then if we want to click that extra set of parentheses, we can type that in. Then we can go ahead and then click the second x squared button. What will pop up is a square root button. Then we type in our 3. Again, you want to make sure if you hit that right arrow button, it won't have the square root sign go anymore. Then we go ahead and click the not divided by yet. We want to click the close parentheses because we're actually essentially kind of putting that extra set of parentheses around here. So we're essentially adding in double parentheses just to be careful, just to be cautious. Okay, so now that we have that, let's click our divided by symbol, type in our 2, and then close the parentheses. So either one of these methods will work. And then when you click enter, let's see what you get. Awesome. You should see when we do this, we should actually get 60 degrees. So it's pretty cool how we were able to walk through and figure that out. So we're going to figure out theta equals 60 degrees. So that's kind of what we're talking about here. This is what we're doing when we talk about that inverse sine operation. Very similar to what we've done up here before. And now you know how to use your graphing calculator as well. So that's pretty cool. That's something that we can kind of, keep off to the side and reference if it is needed. Awesome. All right. Well, let's keep going and start looking at number 2 here. So now, it says use a scientific or graphing calculator to evaluate each of the following to the nearest tenth. It says make sure your calculator is in degree mode. Oh, so that's something else that I actually forgot to bring up as well, that degree mode. So I'm going to go ahead and highlight that. All right. I will tell you most of the calculators on our graphing calculator on our iPad are already in degree mode. But if you need to double check, what you can do is you can tap this mode button. And what will happen is this window will pop up. So I'll zoom in for a second so I can show you that. So this window will pop up when you press mode, again, on your iPad calculator or your normal calculator. And what you want to make sure is that we are looking at the angle part, and it's not in radians, that we are looking at degrees. So if your calculator isn't in that, that's probably why it might be erroring right now if you were going through and trying to type in what we did before. So make sure it's in degrees. Next year in the future, when we do a little bit more trig, we'll talk about radians. It's just another way of measurement. Just like, we have the metric system that we can measure in, or we have different types of systems we can measure in. So that's just something to kind of keep in mind. So putting that off to the side, again, make sure we are looking at degree mode. So keep that in mind. All right. So now what you can go ahead is you can practice putting these into your calculator, again, using the same steps that we did before. Specifically, now you can also look at the inverse of cosine or inverse of tangent. So go ahead, pause the video right here. Go ahead and complete the calculations and round to the nearest tenth. All right, so let's talk about these results. So for A, we should have gotten 30, B, 60, C, when you rounded, 26.6, D should be 48.6, E should be 41.4, and S should be 36.9. Now, remember, the purpose of this is we're finding degrees. So if you didn't put a degree symbol by all of these, I would go ahead and do that right now, because we're looking at, this is the ratio of different side lengths in our triangle, right? Either the opposite, adjacent, or hypotenuse, and we're looking to see what that angle measure is that's going accordingly with it. So using known measures to find all the remaining unknown measures of a right triangle is known as solving a right triangle. So what we're saying here, all right, is that, hey, we can now use the given pieces that we have and solve a right triangle to find unknown side lengths and unknown angles. So here I'm going to clarify. So we will find unknown sides and angles in a triangle from given sides and angles. All right, cool. Let's go ahead and go on to the next page, 315, and start to put all of this together, our inverse trig functions as well as what we've learned previously. So let's go ahead and we are going to zoom in kind of on numbers 3, 4, and 5, and we're going to use the picture over in the margin. So we have Trisha. Trisha designs the logo shown for one of her clients. She needs to know all the missing dimensions and angle measures of the logo. So we can see in this picture right here that we are missing the length of QR, and we are also missing angle Q and angle R. We are given QS, RS, and the 90-degree angle. So to kind of help us walk through this, it starts off with number 3 that says use an inverse trig function to find the measure of angle Q. So let's go ahead, let's look at angle Q right here. Awesome. Well, keep in mind, we don't know what the hypotenuse is. We have to use these two sides. So think about this. This is the opposite side and the adjacent side to angle Q. So think about if we're going to use inverse of sine, inverse of cosine, or inverse of tangent. All right, so hopefully you picked inverse of tangent, right? Because we know, let's say we have tangent of Q, right? We know tangent is always going to be opposite over adjacent, so it's going to be 65 over 33. And like we talked about this, we want to make sure we're doing the inverse, right? We want to take the inverse of both sides, so that way we're just solving for Q, and we're taking the inverse of 65 over 33. So we're going to have Q equals the inverse of tan, and we're doing that of 65 over 33. So go ahead, put that in your calculator, and we're going to see what we get. Now, we technically get a decimal. It doesn't tell us to round to a certain place. Let's just round to one decimal place. So I get 63 points, and I think I'm going to have to round up 1 degree. So I get 63.1 degrees. So I'm going to put that as angle Q. So I end up getting 63.1 degrees. Now, let's look at number 4. It says describe 2 ways to find the measure of angle R. It says without finding the length of the hypotenuse. Ooh, so we can't use hypotenuse. So maybe from what we have, let's see if you can figure out 2 ways. And we're actually going to find that angle measure using both methods. So go ahead, see if you can at least write down maybe one of the ways. Let's see if you can come up with both ways. How do you think we could approach to finding the measure of angle R? So maybe one way that you are starting to look at the measure of angle R is you're thinking about the relationship of sine, cosine, and tangent, right? Again, we could say the tangent opposites over adjacent, right? 33 over 65. We could write it like that. So we could do tangent of r equals 33 over 65. So that way, to find r, right, we take the inverse of tangent. And remember, it's now 33 over 65. So that's one way that we could approach it, right? So let me write down, the first way is really looking at and using inverse trig. So we kind of have, option 1 is inverse trig. So we're looking at option 1 is inverse trig. Again, we could put this in our calculator, figure out what that is. Let's go ahead and do that. And then rounding, let's do, to nearest tenth again. We get 26.9. So that's one way that we can find it. That's option 1. Now, maybe some of you thought the other route, like, hey, it's a triangle. It's 180 degrees. I don't know. Maybe I could, add 63.1 and 90, add them together and subtract it from 180 to find the other one. That's totally fine, right? We can look at option 2, right, is where angles add to 180 degrees. That's option 2. So that's where we could take, we could do 180, and we're going to subtract out 90 degrees plus 63.1. We're taking the total of that and essentially subtracting it out. So, well, what are we going to get? We're essentially going to get 180, and we're going to subtract out 153.1. So, when we do that, again, we rounded kind of on our last number, so we know it's most likely going to be a rounding here. But when we do that, again, we get 26.9 degrees. So we should get the same result both ways, right? It's 2 ways to figure out the same thing. And it doesn't matter which way you do it, but I want you to try both here. That's what I was asking us. Cool. All right. Let's look at number 5 now. Whoa, this is going to be cool. This is going to be cool. All right. So it wants us to describe 2 ways to find the length of the hypotenuse. So now, again, remember, we just found angle Q and angle R. Should probably label angle R, right? That's 26.9 degrees. Now we have to find this hypotenuse, that kind of other missing piece, the length of QR. And we have to find 2 ways to do this? Okay, all right, well, let's just start brainstorming, all right? Start thinking about what's one way, okay? What's one way? Now, maybe some of you went back to the good old basics, right? Good old basics of, I don't know, Pythagorean theorem, PT. Yeah, some of you might have done that. You're probably looking at this and saying, hey, I know what a squared plus b squared is. That's equal to c squared. Yeah, and then, you know what? I'm able to fill in what I know, right? I know my 2 legs. I know my 33 squared plus 65 squared, right, is going to equal my c squared, or AKA if you want to put QR in there, you could do that. I mean, technically, we could put like x squared. We could put c squared. Either way works, right? So let's say we do a little bit of the math. I think we're all familiar with how to do this. So if you want to do out the work, great. I'm going to kind of shortchange it, but we should solve for C, and we should actually get 72.9. Now remember, it's units. It's not degrees because we're looking at a certain length here. So we ended up getting the length of Q. Ooh, let's try that again. The length of QR. QR. So that's something to keep in mind. That was one way to approach it. And that's probably the only way that you're thinking of so far. There's actually quite a couple ways to do this, but let me introduce you to maybe just one other way involving those new inverse trig operations that we just learned. So I'm going to introduce that to you. So let's do option 2. Again, we're going to do some inverse trig because guess what? Even though on the previous page We talked about how it's usually used for finding angle measures. We can also do side lengths. So let's look at this, all right? Again, we don't know what QR is. Let's, call that letter C for now, since we use the letter C up here. So we're trying to look for, okay, what's that length right there for letter C? Okay, well, with inverse trig, think about how we already know our degrees and our angles. What we could do is we could set up, a trigonometric ratio and maybe solve for one of the side lengths if we already have maybe one of the angles, something that we already know. So essentially, wait a minute, this isn't inverse trig. This is just normal trig. Wait a minute, I know how to do this. I remember this. Oh my gosh, this looks so familiar, right? So it doesn't matter if we pick sine, cosine, or tangent here because, well, wait a minute. It does matter. We can't click tangent essentially yet because we don't know hypotenuse, but we can do sine or cosine because we have the lengths of our adjacent, our hypotenuse, and we have the sides of our adjacent and our opposites. We don't have the sides of our hypotenuse, so that's kind of what we're looking for. So for me, I'm a sine girl. So I'm just going to click sine. I'm going to type in sine or write it in, and I can choose either one of these angles. It's just going to affect the relationship. So let's go ahead and just pick sine of 63.1 degrees. So we're going to have sine of 63.1, and we know that's going to be equal to the opposite over the adjacent. So the opposite side, oh my goodness, what's going on with me? It's equal to the opposite over the hypotenuse. So opposite side is 65, hypotenuse is C. So I'm going to go ahead and put 65 over C. Now, how do we solve for C? Remember, when we have our variable low, you flip them, bro, right? Remember from what we've learned before, possibly, maybe? You're actually going to see a video later on today that talks a little bit about and kind of reminds you of what you can do with that. But we can essentially rewrite this as C is equal to 65 over sine of 63.1. Now, when we put this in our calculator, remember, we got to put some parentheses around this. There might already be a parenthesis there, so you can double parenthesis it, but let's go ahead, put this in our calculator, and I want you to figure out, hey, do I get 72.9? So go ahead and test that out right now. All right, indeed, we should get 72.9 units. So just like before, again, both of these should be the same because if we have multiple ways to approach this, we should get the same result, right? Now, there's a lot more ways than just 2 ways. I actually think last year I was able to find 7 different ways or quite a couple different ways with my other students to do this, but I just wanted to make sure I didn't overwhelm you and just reminded you of trig. Inverse trig involves the inverse sign like what we have up here. Normal trig does not. Look at us going through a whole bunch of problems, trying some things together. Sweet, this is awesome. Okay, now we're going to go ahead and go look at numbers 6 and 7 next. So I know I might need some room in the margin, so I'm going to give myself a little bit of room. And let's go ahead and read these problems together. So number 6 says, what is the minimum amount of information needed to solve a right triangle? And it says to kind of explain. Well, let's go ahead and not do the explain part, but talk about it together here. Think about back up to here in these previous problems. Think about what we needed to solve for missing angles and sides. Think of when we write our trigonometric ratios, if we're solving for the angle, or even if we're solving for the side. Think of what we really need. So down here for number 6, what we're going to learn and realize, let's try that again. What we're going to realize is we need to have either 2 sides or we need to have 1 side and 1 of the acute angles, meaning not the 90-degree angle, because we have to see how we're going to set it up. We could actually solve for it with these two sides, or like before, we could have a side and one of the smaller acute angles. Now, let's go ahead and look at number 7 together. So number 7 says, explain the difference between the two expressions of sine of 15 degrees and inverse sine of 0.2558. And then it says, how are the expressions related? So let's think about this. When we have sine of 15 degrees, that means we are calculating a ratio. So we're going to say that calculates a ratio. All right, a comparison of the two side lengths we're looking at. While if we look at the inverse sine of 0.2558, that means we're calculating an angle measure. So that calculates an angle measure. So we can easily see that if I pulled up my graphing calculator and typed in sine of 15, let's see what we get. Hey, don't we get the ratio that's typed in here? We do. Well, let's see if I typed in inverse of sine of this ratio. Let's type that in and see what we get. Hey, what do you know? We get, kind of just about 15 degrees. I think it's like 4.9 something. So we can see that the 15 degrees is the angle we're looking at. And the 0.2558, that's the ratio for that angle measurement. So that's pretty cool to see that. Awesome. All right, so let's go ahead and start looking down below at number 8 and 9. We're going to go ahead and look at those problems, and those are going to be the last ones that we go through. So you can cross out 10 and 11. We're going to go ahead and look at numbers 8 and 9. So number 8 says angle X is an acute angle in a right triangle. What measure of angle X makes each statement true? So it says round angle measures to the nearest tenth. So here, if we look at these problems, we can see that we're looking for the angle measure. We're given the ratio, right? The adjacent over hypotenuse for cosine, the opposite over adjacent for tangent, the opposite over hypotenuse for sine. So we're actually going to have to use our calculators here. So I'm going to make a note that says use calc, all right? And remember, what we're going to have to do is we're going to have to do the inverse. So you're going to type in the inverse of cosine, and then you can type in our ratio. So you're going to tell me when you hit enter what you get as that angle measure. So go ahead and type that on in, the inverse cosine of 0.59. So what we get is our angle measure of X. Let's say, nearest tenth, it's going to be 53.8 degrees. So pause the video right now. I want you to go ahead and try parts B, C, D, E, and F. Type those in the calculator and see what you get. All right, let's test these out. You should have gotten X is 75 degrees for B. X is equal to 60.5 degrees for C. X is equal to 10.2 degrees for D. X is equal to 88.9 degrees for E. And for part F, you should get 71.8 degrees for X. So now let's go ahead and look at number 9. This is going to be a lot of you practice that we're going to do. Don't worry, I'm going to do it as well to kind of help you set up how you're able to go through these. But this is your opportunity where you can go through and practice solving for some of these right triangles. So let's start off looking at part A of number 9. So we can see when we solve, that means we have to fill in the missing pieces that we don't know. So let's say we don't know what AC is. Let's put that as X. Let's put BC as Y. And then let's put angle A. Let's just go ahead and put that as theta, one of the missing angle measures, okay? So we have to solve for X, Y, and theta for part A. So you have to think about what do you know in order to set this up. So I want you to go ahead and pause the video. See if you can set up each of the parts to maybe solve for X, Y, and theta. So go ahead and set those up. All right, for x, I'm thinking since I have angle measure 49, right, and I have the hypotenuse of 27, it might be good to set up a sine relationship since we have opposite over hypotenuse. So to find x, I would probably do sine of 49 degrees equals x over 27. To solve for y, all right, looking at this, I can tell, again, I have 49 degrees. I have my hypotenuse, so I probably want to do cosine of 49 degrees equals y over 27. So I will do cosine of 49 degrees equals y over 27. And then last but not least, to solve for theta, again, I could probably use some of the information, like if I solve for x and y, I could use that to help me find theta. For me, I'm just already thinking, hey, it's 180 degrees. So can't I do 180 and then subtract out, right, 90 plus 49 degrees? Yeah, I could totally do that. So I'm going to go ahead and give you an opportunity right now. Pause the video and see if you can figure out how to solve for x, y, and theta. All right, let's go ahead and talk about this. So you should have gotten x as around 20.4. I just rounded to one decimal place because it just instructed me to do that. Y should be 17.7. And your theta measurements, I should have probably put that in there. Your theta measurements should have been 41 degrees. All right, cool. Okay, let's go ahead and talk about part B now. So part B, let's look at what we have. So we have two angle measurements. Awesome. Wait a minute. We don't have any sides. Are we able to solve for sides if we don't have any side measures? This is actually one of those funny problems. We actually can't. This cannot be solved. So that's what I'm actually going to put for part B. So it cannot be solved. Now the reason for that is let's think back and look back at what we said in number 6. What requirements do we need? What's the minimum amount of information needed to solve a right triangle? We need two sides or one side and one acute angle. If we have two acute angles, it does not work. We need at least one of the sides. So that's why. All right, let's zoom in to C. All right, let's look at this. All right, for C, I can see I have two sides. I am able to solve this. So I'm kind of looking for these two angles. So again, we can put the angles as any measurements or any label that we want. So let's have this be angle X. This will be angle Y. Let's see if below, if we move down here, if you were able to, for part C, to see if you can set up kind of a trigonometric ratio to solve for X and Y. Go ahead and see if you can set them up. Okay, let's go ahead and kind of talk about and see. Great, what we can go over. Perfect. Oops, you know what I'm going to do? I'm going to go ahead and label Y inside. I'm going to label it inside the triangle just because I kind of know what's going to be happening because we're going to need the side length. So that's Y, and then maybe, I don't know, the side length is Z we can find later. So for X, I know that I have, right, opposite and adjacent side. So I know I have to use tangent. Essentially what we're going to do is we are going to use inverse tangent. So we have inverse tangent of 9 over 15, and that's going to be equal to X. So that's what we can put in our calculator and figure out what that is. I will go ahead and type it on in, see what we get. Awesome! We end up getting X is going to be equal to 31 degrees. So nice. Now, looking at Y, again, we have, an opposite and adjacent. So ready? We're going to do the inverse tan. Now we got to make sure we have the order correctly. We're going to do 15 over 9 this time. Again, that's going to solve for Y. So let's go ahead, put this in our calculator, see what we can get. Hey, it's actually going to be 59 degrees. So maybe we'll put an equal sign there. Beautiful. Perfect. So let's think about, how can I solve for Z? How can I solve for that third length? Think hard. It's something we were assessed on our last assessment. Yes, it's going to be Pythagorean theorem, right? So we have our 2 legs squared equals the hypotenuse squared. So we're going to have 9 squared plus 15 squared is going to equal z squared. I'm going to go ahead and walk through this a little bit faster. When we actually solve for z, and we might have to kind of round for this, we should get around 17.5 units. So good job using those to figure that out, all right? Now, I'm going to actually have you go ahead and we're going to do the last one, but I'm actually only going to give you the resulting answer. So I want you to go ahead, pause the video here, see if you can do part D on your own. All right, so for part D, if you're able to set this up right, for QS, that length should be around 23.4 units. Solving for angle R, right, we should get 22 degrees. And then solving for the hypotenuse side QR, we should get around 62.6 units. So hopefully you were able to do those right. Again, we're going to do more practicing tomorrow in choice breakout rooms on what we need to review. Maybe some of you want to review solving for triangles. Maybe some of you want to review trig stations. You're going to have that opportunity tomorrow. So if you have Miss Graham as your teacher, we do have a little bit of homework tonight, but it's really only 3 minutes long, exactly 3 minutes long if you start it exactly right away, okay? So there's this YouTube video called Getting Triggy with It that was made by another high school that really goes through and starts to look at the different ways that we've looked at trig functions in geometry. So that's all you need to do for your homework, so you can go ahead, stop the video here, and go out and do your homework. I'll see you tomorrow.